Welcome to another video in Nash School's data science series. This video is on probabilities. When we talk of probabilities, the first thing that comes to mind is simple experiments that we learn in school. We learn about coin tosses, dice throws. These are simplistic and you could say boring. How do we explain probability in the context of real-world experiments? Let's consider a real example. An automobile manufacturer wants to set up a plant in an area and they want to get a good idea about the local demand. So they want to know what cars people drive in the area, how old the cars are, how many miles the cars have run, what models do people like the most. Of course, if there's a database with which they can get this information, then the task is simple. There is no experiment here, there is no probability. But let's say they don't have such a database and they have to learn it by sampling people. So they set up a team. This team is tasked with surveying people. So they randomly select cars. They go around asking people if they're happy to provide the information, and they use this information to create some sort of mini database with which the organization and its data scientists can make informed decisions. Now, where does probability come into the picture in this question? As I said, if there's a database, then there is no experiment. But when we are randomly sampling cars, there is uncertainty because we can only sample a subset of all cars in the area. So the randomness comes in the selection of cars itself. So let's consider this random experiment from the lens of the three important factors of probability. So how do we describe a random experiment? Using three factors. Number one is the sample space. The sample space is the set of all outcomes of the random experiment. So for the simple throw of a die that we learn in school, the sample space is are the numbers from 1 to 6. Simple. So what about the sample space in this experiment? Here, it is the set of all cars in the area because the selection involves cars. So the survey people are going to randomly pick cars in the area and there's only a subset of cars that are going to be chosen. So the whole sample space is all cars in the area and one car in the area is 1 point in the sample space, just like the number 1 or number 2 on the die. The second factor in probability is called the event. The event in a throw of a die is combination of outcomes. So if you look at the sets 1 and 2 together, that is one event. You could ask about the probability of either 1 or 2 throwing up on a die. Or you could ask the probability of a prime number appearing on a die, which is the set 2, 3 and 5. That is another subset of all possible outcomes. In our experiment, the principle is quite similar. Any combination of cars, any subset of the set of all cars is an event. So one event could be the set of all red cars, another event could be the set of all black cars. A third event could be the set of all cars manufactured in the year 2022. So all of these are events and the company might wish to know the fraction of all of these events, which is what is the fraction of cars in the area which were manufactured in the past year? What is the fraction of black cars in the area? How does this fraction compare with the fraction of red cars in the area? So on and so forth. So now that we have 1, the sample space, and 2, the events out of the way, we'll focus on 3, which is probabilities. So once we have the events, which are combination of outcomes, 3 probabilities is going about with the survey and determining the fraction of each of these events. As I said, the fraction of red cars, fraction of black cars, so on and so forth. So we need numbers for all of these fractions in order to complete the experiment and describe the experiment using the 3 factors: sample space, events, and probabilities. So are we done with the experiment? Yes and no. We are done with the experiment, but then businesses may not like this explanation. The whole world of sample space, probabilities, and events is like so abstract. And do you know what business is like? Hard code numbers. And we are not anywhere close to numbers in the three factors that I described. So how do we move from this abstract world of probabilities to real numbers that people can use in daily life and businesses can use to make decisions? The tool which can help you move from probabilities to numbers is called the random variable. The random variable is simply a map from the sample space to a number. It can be any relevant number. For example, there could be a random variable of the year of manufacturing. So every car in the area can be mapped to a number which is the year of its manufacturing. There could be a second random variable which pertains to the number of miles that the car has run. So this random variable maps an individual car to a number which is the number of miles it has already run. And there could be a third random variable which deals with color. So any car in the sample space can be mapped to a number, and that number could stand for a particular color. You could say black for 0, red for 1, gray for 2, so on and so forth. So you're mapping cars to a number which corresponds to colors. So once we map cars to numbers, we can do interesting analysis. The numbers are interesting to people. We can create distributions, we can create histograms, we can compute averages, standard deviations, and we can compare different cities. Should the business set up the manufacturing plant in this location or in some other location? How will the demand be different in two different locations? What will it mean for the business? Are cars likelier to sell in locality A as opposed to locality B? Those are interesting questions for businesses to answer, and these can be done only if there are random variables. Let's talk more about random variables and distributions in the forthcoming videos.